Hello everyone, welcome to the discussion session or tutorial number 4. On this video, we'll try to cover question number 2 on Gabion retaining wall design. The figure 2 here shows a typical cross-section of a Gabion wall where the total height of the gabion measured parallel to the face of the wall is given as 8 meters, of which 1 meter is buried at the toe depth. The structure is to be battered at a battered angle of 8 degrees to the vertical. A surcharge of 18 kN per meter square, equivalent to the soil layer of 1 meter, is to be allowed for at the top of the wall. The effective angle of friction of the backfill is conservatively estimated as 30 degrees, and the unit weight of the backfill is expected to be 18 kN per meter cube. We are required to find the active force in the wall, that is this PA value. So let us now try to illustrate what is there on our diagram. As you can see, the cross section of the gabion wall given to us, it resembles a practical situation of a gabion like here in the figure. As you can see on the figure, the gabion is basically a steel wire mesh where rock particles or rocks of different sizes are inserted in the gabions and assembled one another so that it can form a wall. Here on the figure, there is no inclination of the backfill, so the beta angle is 0 degrees. The battered angle 8 degrees can be shown here at the bottom. 2 meter is given on the question from the toe to the top of the gabion. The angle alpha is basically this angle AB and whatever we have at the batter. This angle in vertical direction at the end of the gabion, we can represent it by I. Now, using our trigonometric calculations and ratios, we can try to estimate the other dimensions in adjacent to the gabion. Firstly, if you want to find what is this length of line A prime B, we can easily determine using this formula HA equals to A prime B, where we have the cosine of the I angle. This I can be determined from 90 degrees minus alpha. And we can easily determine this alpha from this triangle ABC double prime, where we know this base BC double prime equals to 2.5 and AC double prime equals to this height of the gabion 8 meters. Now, also, we know that the phi angle equals to the delta prime, which is not equals to 0. Now we can use formula Ka delta to find the active earth pressure coefficient along the wall. Now, I can see we need to find this value of PA, which is oriented at an angle of phi prime, which is equals to the delta prime, has a vertical component PAV and PAH. Now from this line A prime B, we can calculate the vertical effective stress that develops at the back. So this height is, as we have done in the previous example, is coming from the surcharge, and along the depth, when we go to the HA, we can find gamma times HA, the increase in the vertical effective stress. Now, if we know this Ka delta, as we calculated in the previous slides, we can easily calculate the active earth pressure distribution by multiplying the vertical effective stress with the value of Ka delta. Finally, we can use this formula act for the active force on the wall, PA times half of HA times the value of here and here, which basically is the area of this trapezoidal, will give us the active force per unit length in delta direction. So that is what it was asked in our question. So that's all for question 2. Thank you.